Whether it is a relation or a function, it's a collection of points. And basically what domain and range do is it basically organizes it and tells us what points are part of our function. Remember, it's just a collection of points. Even when it's a line or a curve like these ones right here, it's still just points. They're just connected in that case. And we'll talk about how to deal with that in a second. But first, in terms of what is domain and range, I don't know why we give them those names, but domain is your X, range is your Y. So on the study island, it may ask, what is the domain of this set of points? You're looking at just the X's. If it asks for the range, just the Y. I don't know if you want to write that down, screenshot that little bit right there, but domain is X, range is Y. All right, so if your collection of points is literally just a collection of points, what I mean by that is it looks like this. It's just a bunch of points on a graph. It could be listed like this. So these are all points. On Study Island, you might see it like this, just listed as a bunch of points. It's the same thing. And you'll see it in these funny looking brackets. Same thing, and in fact, I'm going to write it like that just so we have a different way of looking at it. If it is a collection of points, super easy. Remember, and I'll do this one first actually. Domain is X, range is Y. So if it's in a table, it honestly organizes it for you. And then even same thing here. All of your X's are your domain, and all of your range is your Y values. And so on the study island, you're just going to have to identify that. But what it'll look like is for these, when it's a collection of points, domain. And if you have to write it out, come back to this video, you're going to write out all of these and you're going to write it in order from least to greatest. No repeats. Your domain is, and I should have done it in red, but domain is all of your X values, -2, 3, 5, least to greatest, and you don't have to repeat that 5. And then range is going to be, what is that, 2, 4, 6, 7. And that is it. All right. So it's just a way to organize what points, what X's and what Y's are part of our function or our relation. Now, like this one is not a function. You should remember that because if we draw a line, it hits a bunch of points. It should only hit one point at a time using our vertical line test. That's not important here though. All we want to do is list out the domain, which is our X values and our range. Now, when it comes to a bunch of points on a graph, you have two options. You can either do it by just looking at it, or you can list out the points. I'm going to list out the points for now. And what I mean by that is this point right here that I just barely highlighted in blue is 1, 2. Right? And then we have a bunch of them on 2. You got 2, 1. You got 2, 3, and 2, 5. You can just list out the points, and then this one would be 4, 2. It's just listing out the points, and then our domain is just all of the, do it in a different color here, X's. 1, 2, 4. We don't need to repeat the 2's. Our range, boom, 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 boom. Got 1, got to repeat 2, 3, and a 5. All right, so if it is a collection of points, so I'm going to do 2 more examples very quickly. So like here, let's look at our domain. You don't want to write out the points, do it this way. Here's your x-axis, right? Look at what we have. We have a 1, we have a 2, we have a 3, we have a 4, we have a 5, we have a 6. Cool. And for the y, go to the y-axis. What do we got? We got a -1, we got a 0, a 1, a 2, a 3, and a 6. You can just eyeball it by looking at, we have a -1, 0, 1, 2, 3, and a 6. You don't have to write out all of the points, basically. And even here, I'm not even going to write it out. Wait, is that a repeat? No, I think that is different. This would be your domain. I will write it out actually, because it's not that bad. You don't have to, again, you don't have to write them out as points, just, that might have been a repeat. I might have accidentally. All right. Is it? No, it's not. Okay, we're good. All right. So these are basically just collections of points. Here's what happens though when we get to this. And actually, I'm going to start with this one right here. This is a continuous line. So that means, yes, there are points, right? In fact, there's a point right here. I'm just going to call it 8, 2. Even though it's a little bit above the 2. Excuse me. That point is included, but so is every point along this line. And because they're connected, it includes every little dot along the way. So there's no way for us to list out all of the points that are included in this function. And it is a function. So if we can't list out all the points, what are we going to do? We still want to communicate all of the x's and all of the y's. So this is what you're going to do. First off, this stops, as in this stops. That's what those dots mean. These arrows mean it goes on forever, so it's going to be a little different. Since it stops, that means that we have a point that basically, beyond that point, there's not going to be any x's, right? So for domain, this is where it gets a little trickier. For domain, we're looking at this axis right here, all of the x's that are included. Now, there are no x's out here, so at x equals 10, there's nothing out here, right? X equals 9, there's nothing out here. You can actually color in until you hit that point. But at 8, we have an x right here. So it starts right here, and then it's going to go until it hits, what is that, -3? -3. There are no points out here on the x. There are no points at all, so there's definitely no x values. So all of our x's are between 8, it's our biggest, and we're going to write it using inequalities. And it's equal to, it's a solid line, down to, I'm going to have to erase that in, -3. So basically, how far over does our graph go? To the left and to the right. That's that right there. Okay, what about for the range? How far up and down on the y? So you can kind of color down to, and I'm just going to say that this is -2, or I'm sorry, 2. I'm just going to say this is 2, just for the sake of making it easy for you. 2 is our biggest, and it is a solid line, and our smallest, as in how low does our graph go? There's nothing down here until we hit, I'm going to call that -5. So that means on the y, we start at 2, and we go down until we hit -5, and that's basically like a box, right? Our graph is contained in the box. The red represents our domain, how far over, left and right, and range is how far up and down on the y-axis. And it's written as an inequality. So you're just looking for the highest and the lowest point. Now, same thing here, but there is a twist. These arrows represent, these arrows represent the fact that this is going to go on forever. So that means that, will we ever not have an x? As in, if we go to here, there's going to be a point down here, right? X is 5, there's going to be a point. What if I go out to like x is 100? Will we have a point there? Well, it's going to go on forever. What about at 1,000,000? The answer is yes, because this goes on forever. And same thing over here. If I go out to, I can't draw, -1,000,000 or -1,000, this is going to go on forever. So we're always going to have x values, always. Also, think about it this way. We colored where we didn't have points, right? Can we color out here? Well, no, because this is going to go on forever. Where are we going to start coloring? Well, we can't. So what that just means is that for the domain, you'll probably see this in the study island, infinity to negative infinity. It goes on forever. Now what about the range? Now, it's going to go down forever. So it's going to go negative infinity. Right? We can't color down here because, well, this is going to keep going. So we're always going to have negative y values. But what about up here? Do we have a starting spot? If I pick the y6, do we have a point? Well, no, not on our curve. We can color down to, I think that's 3. So 3 is our highest y. That's where our graph starts on the y, and then it's going to go down forever. All right, super briefly. Now this one's not a function, obviously, because it's on its side. If we drew a vertical line, it would overlap. But real quick, it has arrows, so that means it's going to go on forever like this. So on the x, and you can do this too. Here's our x-axis. Is there a starting spot? Well, yeah. In red, it starts at 0. So 0 is our lowest, and then it goes on forever. As in, it starts here, and it's going to go that way on the x forever. Now, what about on the y? Well, it's always, can we color it? Can we color up here? Well, no, there's going to be points. There's going to be points. So the range is going to go on forever in both the negative and positive direction, because this is going to keep going up, 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 up on the y, and this is going to keep going up, 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 or down, 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 down on the y. All right, this one, again, it has ending points, so you can color in and box it in. So at 4 on the x, negative 2. So the domain is, I'm just going to keep it like that, negative 2. And it's a solid line. This is an open line to 4. From 2 to 4 on the x. What about on the y? 2 is our highest, and negative 3 is our lowest, as in from 2 to negative 3. Or negative 3 to 2. All right, that's it.